these special products are so important, then you will see, I don't want to say 100%, but at least 90% of our classes, of our meetings, will have something to do with this. So this is extremely important. I want to establish this from now moving forward and not worry about it. Can you still ask questions about this later? Yes. I'm just hoping that we can start with this and put it aside and say it's done. I know it, I understand it, I remember it, moving forward. Okay, so let's start by looking at this a plus b. Terminology is very important. It's important to understand what we are trying to do, and it's important to refer back to it, right? If we don't know what this is, then we may have difficulties working with it. So does anyone remember what this is? How is it called and what does it mean? Tyler? So these are two terms because they are added or subtracted. Any two quantities that are added or subtracted are called terms. If they're multiplied, so if I have a times b, how are they called? They're called factors. Okay, so two terms, and we have a special name for two terms when we add them, subtract them, terms. What is this called? It has a name. Anyone remembers?
Binomial.
Thank you. Thank you, Garrett. Excellent. Yes, it is a binomial. It has two terms. We add them or subtract them, two terms. Good. So does anyone remember how to square? What is it again? What do we square here? A binomial, right? Okay, so we square binomial. So what would you say? So we want to square a plus b. So what do we get? If you remember. If not, we're going to build it one time.
A squared plus b squared.
Say it again?
A squared plus b squared.
Okay. Before we write that, I hope you agree that this is a plus b times a plus b. Would you agree with that? Okay. And how do we proceed to expand this? We're going to use FOIL. I agree. Good. So let's multiply a by b, and then b by a, and b by b. What do we get?
A squared.
Do you all agree? A times a is a squared, a times b is ab, b times a or ab, same thing, plus b times b, which is b squared. Do you all agree with that?
Yes.
Perfect. Obviously, these two are called like terms. And now I'm going to stop for 1 second and show you, which I recommend. A student from my previous class said, what about index cards? Fine, whatever works. Get a notebook or a notepad or something small, maybe thick, whatever, in which you write down all the important information of the day. What will I write already? I will write what a term means. I will write what a binomial means. I will write how to square a binomial. I will write what the answer is, and review this. As many times as you review it, the more review it, the better off you are, the better understanding you have of the topics. And moving forward, you'll be able to apply them. They will be sticking in there, and you will remember them. So you may have a different technique. That's fine. Index cards, whatever you want. But I highly recommend summarize every class somewhere so you can go back to it. It would be much easier to access this in review of a test, final exam, than go through all your notes. I will even write down specific problems that intrigued me, or a problem that was, proving something, some topic that I didn't know about. So I highly recommend that. Okay, next step. We will combine like terms. So this is a squared plus 2ab plus b squared. So now I'm hoping that moving forward, no one will ask, wait a minute, where does this 2 come from? Because I will answer, Where does the 2 come from? From adding two like terms. Good. But so now we can go back to our handout and we can write a squared plus 2ab plus b squared. That's good. But what is important to remember here, it's not a and b, because I'm going to change the problem, let's say, into 3x plus 2y squared. And there is no a and there is no b. So what does this mean? It means that this is the a and this is the b. The trick here is, and the most important part is, and you can say, can I live without having to remember this formula or special product? Yes, you can. Can I live quite well? Can I go through math without learning to factor? Yes, of course. But you're not laying the foundation, a strong foundation, and you're not going to be able to make a lot of progress. You're going to hit a wall all the time. Can you still get an A if you foil? Yes. But move away from that. It's not helpful for what follows next, and you'll see factoring follows next. So what I need to remember from this is that this is the first term and this is the second term, correct? What does this mean is the first term squared plus, can anyone help? 2 times the first term times the second term plus? Exactly. This is what you have to remember. That's the pattern, not A and B. A and B doesn't mean anything, right? It's the first term plus the second term, everything squared means first term squared plus 2 times the first times the second plus the second term squared. This is what this means, translated into the first and the second. So now this will become easy. Let's square the first term. What do we get? Very good, 9x squared. Then I have to write plus 2 times 3 times 2. 2 times 3 is times 2, 12, xy. So one more time, 2, the 2, this one, times 3 is 6, times 2 is 12, x times y. And plus the second term squared, which is?
Y squared.
That's it. So there is no need for foiling. But you have to see the pattern. Once you practice it and you see it, you cannot unsee it. Okay, back to our handout. What do you think will happen here? Can anyone give us this special product? We're talking about number 2.
A squared minus AB minus AB.
Right, but now we know what to write.
A squared minus 2AB.
Excellent.
Plus 2B squared.
Very good. That's it. So what do we conclude? That a binomial squared is what? How do we call this? If this is a binomial? Exactly. So this is another very important idea that I would write in my notebook. Remember, a binomial squared is a trinomial. So I will never make this mistake now. Oops, I didn't mean that. I will never make this mistake, would you? Would you ever make that mistake?
Probably.
But not after you know now that a binomial squared is a trinomial and this is not a trinomial. Right? What is this? A binomial. Right? So that will be incorrect. There is a missing term in there, which is 2ab. Okay, good. So let's finish with the third one. Of course, this is totally different than the other two. This is a trinomial coming from a binomial squared. This is a trinomial coming from a binomial squared. This is a different story. So let's give it a shot. A plus b times a minus b. And this is what? Let's use the foil.
It's 1 minus b squared.
Exactly. This is the difference of squares. 1 second. It has bugged me for a second. Because I have to scan these. So before I go home, I scan them and post them together with the video for you. So I didn't want a mistake in there. Okay, perfect. So let's do the FOIL just one time. Last time, a squared, and then minus ab, and then plus ab, and then minus b squared. This time, these two go away. And that's why this is a squared minus b squared, and this is the difference of perfect squares. And is this a binomial or a trinomial? Binomial. So please remember that. Questions for me, please. Yes, please, Alex.
I wrote the right answer, but I had a squared minus ab plus ba. Like that on the point.
Yes, because ab.
Is that like a off of major points?
No, but it's not. You didn't finish. So 2 times 3, you understand, is 3 times 2, correct?
Yeah.
So that's why AB is the same with BA. That's why I wrote it as AB is from the beginning, because it was easier to see that those two terms go away. Any questions so far? Anyone? Okay. So let's look at an example like this, and then start our review of factoring. So give me an example for this last special product.
4x plus 3y.
Okay, let's read 3y to the third.
3x to the third.
And
6x. Or do you want to try? You want different variables? 6x.
let's analyze these two. So they are identical binomials, right? The only difference is that one has plus between those two terms and one has minus between those two terms. If they're not identical, you cannot use the special product. So if the first one is 4x plus 3y cubed, the second one must be yes. Is that clear? Otherwise, the special product has no meaning. It's not a special product if they are not identical, and the only difference is plus and minus. They can be arranged like this or like this. Of course, it doesn't matter. Good. So this is a difference of squares. So let's square the first term.
16x squared.
Do not forget the minus. It must be the difference of squares. And let's square the second term.
9y to the 6th.
Very good. Y to the third, everything squared, copy the base, multiply the exponents. Very good. Excellent. Questions? Questions? Okay, so now let's review factoring. One of your colleagues said, I don't remember any of this. Will you review? And I said, absolutely. Okay, so if you throw any polynomial at me and say to me, factor this, here's how I think. This is what goes through my mind immediately. First of all, I identify the polynomial as being what? Or what is this? Well, they're all polynomials, but this is special, 2 terms, special, 3 terms, and this 4 or more, 4, 5, 6, whatever. Okay? So first of all, I identify which category it belongs to. Secondly, I will follow this path. If it's a binomial, I will follow this path if it's a trinomial, and I will follow this path if it's a polynomial, 4 terms or more. Okay, that's the reason why I divided factoring into 3 different steps: binomial, trinomial, polynomial. And these are applications of factoring. Okay, so let's start with these special products. And we have discussed one of them, just one. Which one? Of course. But remember, we are talking about it backwards now. We are given the difference of squares now when we are asked to go back. Go back where? Well, we are given the difference of perfect squares, and we're asked to come up with this. Later on, we will be given these in trinomials, and we will be asked to determine this. So that's why the special products are so important, because then we're going to struggle. If we continue foiling these, then we're going to struggle going backwards by factoring when we are asked to factor. That's why I insist that we understand these 3 special products. Okay? So we do know this. And how do we factor the difference of squares? Can anyone give us? We cannot take the square root. Very good. Okay. Thank you for saying that. So when we are given, let's say, x squared minus 4 to factor, we cannot simply take the square root, right? If I have, let's say I have $9 in my pocket, and I decide, oh, let me take the square root. Unless I solve an equation, the square root property is not applicable. So this is only for solving equations. It's very important to talk about that early. Thank you. No, the question is how to factor this. So we are going backwards now. We were given this, and we want to come up with that. Yes, Alex?
Separate x to x out. X minus 2.
X minus 2. Very good. This is the factored form of x squared minus 4. We're not solving an equation. Do not get tempted. I know it's very tempting to say take the square root. But you can take the square root in the sense of finding what's in there and how to factor it, but not to solve, if that's what you meant. Is that what you meant? Is that what you meant?
Yeah.
Good. That's good. Okay, so x squared minus 4 factors into x plus 2x minus 2. If you multiply these two, what will you get? Right. Right. X squared minus 4. You square the first term and you square the second term and you have minus in between, as we discussed. Right? Okay, perfect. Back to a few examples here. Let's choose a few examples. I did not go through the other 3 special products. I will in a minute. I just want to pick a problem or 2 to practice the first one other than this. So let's say 4z squared minus 25. Okay. I cannot stress enough. We must go through this strategy. My first question to myself is, what is it?
Answer.
No? What type of polynomial? You're correct. What type? Correct. I didn't specify. My apologies. What type of polynomial is it? Perfect. Is it in descending order? Is it arranged in descending order? Yes, it is, because the term with the variable is first, and the term without a variable follows that. Good. There is a greatest common factor of these two? No, there is nothing I can pull out. Is there a negative leading coefficient? Is the leading coefficient negative? So I don't have to do anything other than now establish which special product, if any, it's not mandatory, if any, is applicable here. Well, we only talked about the first one, so it must be the first one. So it is the difference of squares. And what term squared is this and what term squared is that? So it's 2z and 5. And now how will you tell me, how will you factor this?
2z plus 5 and 2z minus
Oops.
5.
Yes. Yep, exactly. 2z minus 5 and 2z plus 5, correct. Perfect. Let's look at one more and then discuss the other special products. Let's say x to the fourth minus 81. Okay, when we're asked to factor completely till no factor can be further factored. Okay, so then x to the fourth minus 81, I'm going through my strategy step by step. I do not skip any. Extremely important. What type of polynomial is it? Is it in descending order?
Yes.
Is there greatest common factor?
No.
Negative leading coefficient?
No.
No, so I'm down here. Which of the special product? We only discussed the first one, so I'm assuming it's that. And how do I factor it?
X squared minus 9.
Excellent.
X squared plus 9.
And now I want to introduce the second one. We didn't finish. Just want to introduce the second one here. So we know that this is a plus b times a minus b, or in any order you want. But now for this one is not factorable. It's, to be exact, not factorable using integers. Right. So this is the sum of squares. Sum of squares is not factorable over the integers, to be exact. Okay, so which of these two then is not factorable? The first or the second?
Second.
Correct, that stays. But now I can completely factor this. How?
X plus 3 and x minus 3.
It's again the same formula, the same special product. All three factors have to be there, so if you multiply these, you will get that. Any questions? Any questions? Okay, so let's look at the other two special products. They may not be as widely used in this class, but I have to present them to you, so let's do that. The a cubed plus b cubed and the a cubed minus b cubed. They're very different. They factor into a binomial and a trinomial. So they're not a product of a binomial times a binomial or a binomial squared or cubed. No. They are a product of a binomial times a trinomial. The binomial will have the same sign with what we factor. If we factor the sum of cubes, so this is the sum of cubes. And this, of course, is the difference of cubes. So if we factor the sum, the binomial will have the sum. If we factor the difference of cubes, the binomial will have the difference. And right here in the middle will be the opposite sign. If these two are plus, the middle one is minus. If these two are minus, the middle one is plus. So now let's identify the binomial first, and then you will see the pattern here is not that difficult. So what term I cube to get a cubed? Of course. What term I cube to get b cubed? Of course. Okay, now this is a trinomial. I did not mention anything about this last term. Of course, the last term will always be positive. That's why we don't even mention it. So now let's see what we get here. The first term squared, like we had in a previous formula. This time it's just the product without multiplying it by 2, just ab. And the last term is, of course, b cubed. I'm sorry, I meant to say b squared. Same thing here, a squared plus ab and plus b squared. So this is a very similar formula with what we discussed on the first handout, just that the 2 is missing. It's not missing, it's intentional, it's correct. This is what basically comes from the sum of cubes or the difference of cubes. If I have, like, let's say, let's look at one example, x to the third plus 8. Can anyone figure out how to factor completely x cubed plus 8? So first of all, what is the sign in between?
X plus 8.
Very good. What is the sign in the middle? Good. And the last one we don't even discuss. So I'm asking myself, what goes here that I cube to get this? Of course. What goes here that I cube to get this? Of course. So this is really all I need. Now I square this term, I square this term, and in the middle I just put their product. Now you can say, show me that this is the left-hand side. I can. I'll multiply x by x squared, x by negative 2x, x by 4, 2 times x squared, 2 times negative 2x, and 2 times 4. 4 terms will go away, and I'll get this. You want to do that? Yes? No? No. So you are convinced, you trust me. Thank you. Okay, so let's look at and finish up binomials. Let's go back to the handout. And let's choose 1 over 27 minus x to the third. I immediately go to my strategy. So the first question is, what type of polynomial is it? Second question is it in descending order? Excellent. It's not in descending order. So it has to be negative x cubed plus 1 over 27. This is the correct descending order. Is there a common factor? Do these two terms have a common factor that I can pull out? No. Excellent. Is there a negative leading coefficient? Yes, I have to factor it out. You can say that's the negative leading coefficient, that's the common factor. That's fine too if you want to consider that. Now I have to be very careful what is left inside.
X cubed minus 4.7.
Is it me making that noise? Yeah, okay. So we have x cubed.
Minus 1 over 27.
Excellent. So now I'm going through all these because I know all 4. First of all, I see that it's minus. So these 2 are disqualified right away. So I'm only looking at these 2. Then I look at x cubed and 1 over 27, and I'm asking myself, are these perfect squares, or are these perfect cubes, or none of the above?
Perfect cubes.
Say it again.
Perfect cubes.
Perfect cubes. Excellent. So once you say perfect cubes, then you will prepare a what first? Excellent. And prepare a, so it's a binomial times a trinomial, the difference of cubes, or sum of cubes, always. Binomial times trinomial. Let's identify the signs first. What is the sign inside a binomial?
X minus 1/3.
Very good. And what is the sign in the middle of the trinomial?
Plus.
Excellent. And the last one, we don't even mention it. Good. Once I identify the binomial, I'm in business because I can square x, get this. I can square 1 over 3 times 1 over 3, which is 1/9, and I just multiply them to put in the middle, 1/3 x. You understand it's crucial to put the signs in first because if you multiply, you may change the sign by mistake. So always prepare the binomial times the trinomial, then take care of the signs, and then identify the binomial and then the trinomial. That should be the correct sequence so you don't make a mistake. Okay, are we finished with binomials? Would you like another example from here? For example, here, the x squared plus 16, what would you say?
X plus
So it's in descending, it's a binomial, it's in descending order, no greatest common factor, no negative leading coefficient, and a special product. Is there a special product? I have two special products with positive. Is it the sum of squares or is it the sum of cubes or none of the above? So what will you say? What do we know about the sum of squares?
They're
Not factorable over the integers. So there is nothing you can do. You will not find two integers to factor that out. So not factorable. You cannot find two factors to give us that. Okay, perfect. Okay, we move on to trinomials, or we still have binomials on our minds. Moving on to trinomials.
The only thing I didn't understand is how you got 3, 1, 3 X.
Because I know that 1/3 to the third power is 1/27. 1 to the third is 1, 3 to the third is 27. Is that better?
Yeah, what's the 1/9 on the N4?
Because I have to square. I have to square the second term. The second term squared. So if this is 1/3, squared is 1/9. So x squared is x squared, 1/3 squared is 1/9, and the product is in the middle. Is that better? 1/3 times 1/3 is 1/9. And then x times x is x squared. And the product is here.
Oh, okay.
Yeah, that's the pattern, right? So once I identify the binomial, this squared is here, the product is here, and this squared is here. So once we know this, x squared is here, this squared is here, and the product is in the middle. Is that better?
Yes.
Perfect. Okay, so again, this was a month of work in a previous class for 10 minutes of binomials. So which means if we don't practice, we will not remember. By Wednesday, everything will go. So put it in your notes and practice, okay? Good, so let's take a look at how to factor trinomials. And let's start with, I'm going to copy an example, or you choose, please choose any example from here that you want, or any example in general. Let's start with the first one, y squared plus 121 minus 22y. And then you pick the next one. That's from the handout. I copied it from here. Notice now, let's analyze this for a second, that here we only have two special products. How many special products we had to discuss when it came to binomials? We had 4 special products, the sum of squares and the difference of squares, and the sum of cubes and the difference of cubes, 4. And here we have only, and we do know the answer to both of them, because we just discussed that at the very beginning today. So whenever I see a squared plus 2ab plus b squared, I know it's coming from squared, which is
I don't know these terms very well.
it's on the first handout that we worked on.
It's the a cubed minus the
No, careful. It's the first handout. We just filled out the first handout. That's what I'm saying. We need to review these things. Say it again. Exactly. We just wrote that, right? That's why we started with that. That's our agreement. What about the second one? Good. So when it comes to trinomials, our life is a little bit easier maybe, because we only have to worry about 2 special products. So when you throw any trinomial at me, what do you think I'm going to do? I'm going to ask myself what it is. Then I'm going to make sure it's in descending order. Then I'm going to see if all 3 terms have, right, if the leading coefficient is negative. And then I'm going to look at these options. And these are the only 2 special products. These 2 later. we're going to discuss, but these are not special products. We only have two possibilities. This one will be what?
A squared plus B squared.
Careful, that's a difference of square, or sum of squares or difference of squares, which is not a trinomial. So what is this? A minus B, everything squared, correct? And this one is everything squared. Excellent, good. Okay, so then here's our first example. And I'm going through my steps. What is it? What type of polynomial is it? Good. Is it in descending order? No. Excellent. It's not in descending order. Y squared minus 22y plus 121. Excellent. Now it is. Does it have a greatest common factor? Do all these three terms have something in common that I could pull out from all three? No. Is the leading coefficient negative? No. Okay, so now I'm here. These are my options. These are not my options just yet because we haven't even discussed them. So I'm hoping for a special product. Which of these two may be applicable? I don't know. But which of these two may be applicable? The first one or the second one? Right, because the middle coefficient is negative, of course. There is no question there. Good. So now, what do I need to check? I need to check if this is a perfect square. Is it a perfect square? So I expect something like this with minus. Is this a perfect square? What do I square to get y squared? Good. Is this a perfect square?
Yes.
What do I square to get 121? Good. But I have no idea whether this is the correct factored form. Why? Because I have not even looked at the middle term. If this is 7y, this is incorrect. How do I, when I expand this, because we just talked about it a few minutes ago, when I expand something like this, what is the middle term composed of? 2. We already took care of the negative. So 2 times this, correct? So now please tell me what is 2 times this equal to? Is this the same with negative 22y from here? So this must be the correct factor form. What if I ask you now to factor y squared minus 7y plus 121? You will say y minus 11 squared. But now you still have to check the middle term. And the middle term here is negative 22y. But the middle term here is negative 7y. So this cannot be the factored form. So when you apply the special product to factor, you look at the first and the last, make sure that they are both positive and both perfect squares. But you still have to check the middle term at the end of the day because you're not sure whether the factored form fits the middle term. You only looked at the first and the last. Okay, so let's choose another. Any questions for me, please? Any questions? Okay, let's say, what about B? Negative 3 x squared minus 12x minus 12. Is this a trinomial? That's my first question to myself. Is it a trinomial or a binomial? Good. Is it in descending order?
Yes.
Greatest common factor?
Yes.
Very good. Now, obviously, you can combine these two in one step. You can say, I want to do the greatest common factor and the negative leading coefficient if there is a negative leading coefficient in one step. Yeah, I agree. So if we combine those two in one step, what would you pull out?
Negative 3
Excellent. What is left in parentheses?
x squared plus 4x plus 4.
And now I'm hoping for a special product. Is the first term a perfect square?
Yes.
Is the last term a perfect square?
Yes.
What would you write? What is your expectation here? That this changes into
X plus 2.
everything squared. Excellent. Are you certain?
Yes.
Excellent. I'm not. Meaning I still have to check the middle term. What is the middle term of this expansion?
4x.
Right. 2 from the formula that we just started with times x times 2. Since the middle term here is 4x and the middle term here is 4x, I will conclude, yes, that is the correct factored form. Again, it needs practice. I would definitely redo all problems we did in class today. And I know I have 3 more minutes, so let's choose another one or the next step after the special product. So let's look at m squared plus 13m plus 42. I'll stop after this problem. Okay, I go back to my strategy. What is it? Is it in descending order?
Yes.
Greatest common factor and negative leading coefficient? No. Now where am I? So I have to try this, but this is not a perfect square, so this doesn't work. Why am I trying this? Because it's the only one with positive. No way. So now I have 2 options. Is 1 leading coefficient? Yes. So if this does not work, I'm going to write on the side not factorable, or your book likes to write prime. I'm not very happy with that, but that's fine too. Okay, so say it again.
Factors.
Okay, so let's talk about it. So there is no special product, but 1 is the leading coefficient. I'm looking for 2 numbers whose product is 42, the same numbers whose sum is 13, positive 13.
6 and 7.
So here is the thinking behind it, and then yes, you're correct. Here's my thinking. First, I'm looking at the product. If the product is positive, both numbers have to have the same sign. This strategy is very important. If the product is positive, both have to have the same sign. If the product is negative, one must be positive and one must be negative. Since the product is positive, there are 2 options. Positive, positive, or negative, negative. But their sum is positive. Of course, this will not work, because if I add 2 negative numbers, I'm not going to get a positive number. So that's the first step that I have to worry about, a sign. So they are positive, both positive, and indeed 6 and 7. 6 plus 7 is 13, yes. 6 times 7 is 42, yes. Both conditions must be fulfilled. Therefore, the factored form is.
M plus 6 and M plus 7.
It takes few seconds to check this. Here's how I check. M times m, m squared. Positive 7m plus 6m is 13m. 6 times 7 is 42.